I'm Chase Geigle. I'm from the Computer Science Department in the College of Engineering, and I want to talk to you about learning critical thinking at scale, how we can try and teach critical thinking at a scale of the size of MOOCs. First of all, we had lots of really pretty presentations. This will not be one of them, so I apologize in advance for my lack of graphics and rather bad PowerPointing skills. But I want us to think for a minute about MOOCs for critical thinking. In particular, I want us to consider what's missing right now. What are the kinds of things that we ask students that are taking MOOCs? What are the kinds of assignments that we design? Predominantly, these are all things that sort of can be judged in a binary sense. It's either correct or it's incorrect. We have multiple choice questions where it's correct if the student ticked the right boxes. We have short answers where I merely mean short answer, like two-word phrase like the White House, right? Where it's either correct or incorrect. They either said something on your list or they didn't say something on your list. It's either right or it's wrong, right? Programming assignments, okay, we're getting a little more complicated now, but we still have a system where we have a set of inputs, we have a set of outputs, and it's very easy to tell if the program is correct or not based on what it does on those inputs, right? When we talk about critical thinking, it's not black and white anymore, right? We're evaluating someone's thought process. How did somebody arrive at the conclusions they made? What resources did they use? What observations did they make about whatever task is that allowed them to get to their conclusions? So it's not black and white anymore. If you put two experts in and have them do the same critical thinking task, likely they'll arrive at the same conclusions because they're experts, but they'll probably do so in drastically different ways. And we need a way of being able to, now that we're not in the world of black and white, right or wrong, there's a whole class of correct answers, we need some way of being able to evaluate this. There's also this interesting question of how do you offer a critical thinking assignment? Well, what does that look like? It has to be, if it's at MOOC scale or it's even electronic, you have to have some mechanism for students to be able to demonstrate their thought process to you. So it involves an interesting question there. For our particular case study, the applied learning platform was used in the College of Veterinary Medicine to study clinical critical thinking. And so what they're looking at here is a case study that's involving some particular kind of animal, and there's free-form text here that says, what is the animal, how old is it, what's its weight, what did you observe when you got there, and there's also some structured data here like test results. And the student is tasked with making relevant observations, so I think cut off a little bit, but that's okay. They're pulling things out of this data that they think are relevant to making their conclusions about the case, and then once they have those relevant observations, they're filling in a scaffolding that's been provided by the instructor. So this may be something in an outline form, right? So they're putting in their observations here, they're filling in their own text, they're trying to summarize sort of what their conclusions are, how they're getting to those conclusions. And then the question is, how do you do feedback? Obviously the most important thing here is to be able to have this very, very tight feedback loop, and we need a way of evaluating this. This particular study looked at feedback as a multidimensional rubric, so we had a bunch of different dimensions. It's not super important what they are here, but there's a bunch of different dimensions that they're being evaluated on, and it's an ordinal scale from 1 to 5, 1 being a novice and 5 being an expert. And so if we think about how traditional grading works, if you're trying to evaluate critical thinking, even just in a normal classroom, you have to have an expert looking at all of these assignments, right? You can't have, if you're trying to evaluate whether somebody is an expert or not an expert, well, obviously the person evaluating it needs to be an expert. So first of all, finding the person to actually do the grading is hard, and then grading is also hard, and this obviously totally does not scale when you have large amounts of students. And so what I'm envisioning, what we're proposing, is this automated grading system, but automated is maybe not the right word. Maybe semi-automated is the correct word. Something that's working with you as an instructor to learn the patterns that are relevant to your particular assignment, to learn the things that, to learn the rules that it needs to learn to predict the outcomes on for your particular rubric. So it's sort of a collaborative game that you're playing with the system. And so to evaluate whether this is doable or not, again, formatting, we looked at a particular case study. We took a particular critical thinking assignment offered in a real class here, and we evaluated whether or not you could actually grade in a batch setting. What do I mean by a batch setting? I took half of the data and gave the algorithm, the tool, this labeled data for all of those assignments and had it turn and run and try and learn predictive rules along each of the rubric dimensions. And then I took that rule system and applied it to the remaining 50% of the data to see how well it did in predicting the labels for the unseen data, right? just to see if this is even feasible. And what I observed is a bunch of numbers. Most important thing is, in this table, there's lots of bold in the SVOR column, which is the thing that I did. And this, not so much, right? So the interesting point to make here is that some rubric dimensions were easier to grade than other rubric dimensions, right? For the particular set of features that we chose to represent assignments with. The question that this brings up for me is, how do we design assignments that are more amenable to automated grading? Clearly, if we're looking at just this dimension, which is the quality dimension, I believe, and this is the clarity dimension, in that rubric, it was easier to grade the quality, but not so clear to grade the clarity. So can we think about how to make rubrics that are more amenable to these kinds of automated systems to enable us to scale our classes? How do we think about grading our assignments in a different context? The other observation that I'd like to make here is that these were very, very basic, simple features, like what words did they use, or what tests did they pick, or what percentage of the tests did they pick that an expert also picked. These are all things that are general enough that you could apply to any sort of outline assignment. We didn't really leverage a whole lot of domain-specific knowledge here to do this, so there's obviously lots of room for improvement. So some challenges and remaining work. There's, from the algorithms perspective, well, batch learning maybe doesn't really make a whole lot of sense. Am I really going to grade half of my MOOC before I actually run the system on the rest of the data? Obviously not. So maybe there are different algorithms that we can apply, like active learning, where the system is trying to present the most. I think I'll learn the most from this example. Can you please tell me what the grade was? I think the grade was this. Okay, great, thanks. And I'll try and get as much knowledge of that out of that particular assignment, and then suggest the next best one that I think I'll get more information out of. This is the most different one compared to the one that I just saw, or something, right? So there's interesting questions of what is the right framework to design these algorithms for me as a computer scientist. Is this really a classification problem? Do I want to actually predict the grades, or do I want to just order the students by goodness on a particular dimension, right? What is most useful for us as educators? What's going to help us to make grading efficient? What do these systems look like? What should the design of this system be? And then again, from the teacher's perspective, how do we design auto-gradable assignments? Because this is going to be crucially important as we try and scale education up, even at a non-MOOC scale, but certainly at a MOOC scale.